Hello everyone, this is Kalam Khan from India and I have been teaching mathematics since last 6 years. Currently I am teaching at Jail Batir International School. The school follows the Cambridge curriculum and I'm really excited to demonstrate a lesson on vectors. Today we are going to explore the vectors chapters. So vector is a fundamental concept in maths which tell us to understand the movement and analysis of forces in physics. In simple, vectors are everywhere and we are going to understand in the lesson. So let's get started the chapters. So by the end of these chapters, you will be understanding how to write in a standard how to write these vectors in a standard way, and then how to do the algebraic expression like addition, subtraction and other operation on vectors. And then at the end of chapter you will be understanding how to interpret vectors operation geometrically. So let's start it. So I have taken a screenshot from the Google map, and in the map we have a 2 points. One point is Galaxy International School and one other point is Family Park. So we have a point A and point B, and if I ask you one question, how would you describe the movement from Galaxy International School to Family Park? So some student may say teachers is a 700 meters northwest, and some would say uh, you go straight for 200 meter, then turn right, turn left, and then 500 go straight. And then some would have said it's a diagonal path. So if you see from the responses from the students are uh, consist only on two things. First thing is on distance and other thing is direction. So just remember here we need to understand in mathematics we use vector to describe the movement or displacement. So if you see this yellow line shows the displacement, how far they are. So if I need to describe the movement from the Galaxy International School to Family Park, I need to use only two things. One is distance, and distance can be my magnitude, and other thing is direction. So we need only two things to describe the movement. One is distance, which can be magnitude, and other thing is direction. So in mathematics, if we have a direction and magnitude, that thing is called vectors. Simple. So vector has two things, one is magnitude and one is direction. So always remember that in vectors we will have a head will tell the direction and the length of arrow will tell us the magnitude. And now for example, in real life example, if we see when we use a GPS, it calculates the vectors to guide us from one place to another, and it tells how far you have to go and in which direction you have to move. And we in mathematics to write the vectors, we have a way to represent the vectors. There is a standard way. So if I say I have a point A which is 1 comma 2, and I have a point B which is 4 comma 6. It means we have a two coordinate point. So I can represent uh, these uh, these vectors in a standard way, like AB is equal to 3i plus 4j, and this 3i plus 4j is a standard notation of vector AB, which 3 means where I and j represent movement in x and y direction respectively, and where 3 tells us 3 unit movement in x direction, and 4 means 4 unit movement in y direction. That's so simple. Now if I ask you one question, if I have a point C which is go-kart, if you see on the left uh, top corner, uh, how would you describe the movement from point B to C, like as we have described point A to B? So that's the question. I would come again on this question at the end of this lesson. So you have to how would you describe from point B to C? Now let's try to understand, if I have two vectors, vector AB and BC, how can I add them? How can I find the resultant point if I have two vectors or three vectors? Let's try to understand the addition of vectors. So here first you need to understand, this is the shape of vectors where we have a head tells us direction and the length of arrow will tell us magnitude. Now let's take one example, and I have taken one grid papers or graph paper. On this grid papers I will take vectors a, which could be my a is equal to 2i plus 3j. It means 2 unit movement in x direction, 3 unit movement in y direction. And then I have one more vector b. So if I need to add these two vectors, what I have to do, I have to use head to tail method. Head to tail method is what, we have to take a tail and we have to touch one vector tail to another vector head. Like this, if I take this vector b tail to touch vector a, so I will get the resultant point. If you see this orange line tells us this is my resultant, and the resultant point will be 6 and 4. So this is the way where we can add the addition of vectors, and this could be called as uh, addition of vectors triangular method. So we need to make the triangle. So one we have triangular method and one we have parallelogram method. That parallelogram method we are going to see in next slide. So we can understand these all things mathematically. If I say, if I add a plus b, vector a plus vector b, so I have to take vector a and vector b together, and we have to take the like terms, the green, one minute, these these 2i and 4j which are in the green part, these two vectors are like terms, and we can add them together. Like terms can be added together. So 2i plus 4j can be written as a together, 3 plus 1 can be written as together. So if we add them, so at the end you will get 6i plus 4j, which means 6 unit displacement in x direction and 4 unit displacement in y direction. So we can get resultant by mathematically, and we can get geometrically. So geometrically it's easy to understand, it's a head to tail method, or you need to just make the triangle, and it does not matter if you add a plus b or b plus a, you will get the same resultant, so both are correct. Now if we have understand this addition of vectors, then we need to understand one example, like 500-meter. If imagine you walk 500-meter east and 700-meter north. So for this I will take one example. This is the map of Taj Mahal, which is in India, and seventh wonder of seven, this Taj Mahal comes in wonder of seven. Now if I ask, imagine just you walk 500-meter in east direction, and then 700-meter in north direction, and then 600-meter in again in east direction, and then in north direction 250 meters. So if I need to find the resultant, what I have to do, I have to add all the distance which I have walked in east direction, and I have to add all the distance which I have walked in north direction. So let's see total how much distance I have covered in east direction. So total we have covered 500 and 500 plus 600, so total 1100. So 1100 in east direction, and total in north direction 750 plus 250, which is equal to 1000 meters or 1 kilometers. So we have walked in north direction. Now the resultant point is, this is my resultant point. If I this this circle would be my resultant point. So this is my resultant point, Now, so it does not matter if you have, let's suppose this is my vectors. If I change this blue purple color, so this is my one vectors and this is my other vector. So if I have two vectors, I can add them, and it does not matter how many vectors we have, just we need to add uh, x component and y component. So this 500 could be your x component and this 750 could be your y component. So you have to add x and y component. Let's try to understand more. I have this. So here this 8 is my x component and 26 is my x component. So I can add together, and y component 13 and y component 7 I can add together. So these two parts I can add together and then I can find the resultant. This is how we add the vectors. So x part and y part you can add, or we can say these are the components we have to add together. So if we have 3 vectors or 5 vectors or 7 vectors, it does not matter, we have to just add x component and y component. Now once we understand this addition of vectors, let's try to understand subtraction. So again we will take the two example. One, I have a vectors, these six vectors, and other vector is the same vectors, vector b 4i plus 1j. Now if I need to subtract, then I have to go in a same way. I have to go as we are adding the vectors, and we have to take the reverse vector of b. So if I take the reverse vector of b, then I have to go in opposite direction, as you can see, and then this point will be my resultant. This point, if you see this one point, this point will be my resultant. So I can see this is my resultant, and this minus 2 comma 2 I got the resultant point. Now we can get this mathematically as well. If I say a minus b, so again we have to combine like terms together. So 2i minus 4i together, and then I can get the answer minus 2 plus 2j. So once we understand, like this is the same operations that we have done in addition, and only just you have to remember these two things. You have to take the reverse and you have to add to the first factors. That's so simple. Then once again the same example if I take. So let's suppose I walk in 2 kilometers in east direction, 3 kilometers in north direction, which is my vector a, and I can write here this is my vector a and vector a, and then again we walk 4 kilometers in west and 1 kilometer in south. That's the my vector b. So here somewhere I will get my resultant point. Now let's try to understand the next thing, scalar multiplication. So scalar is a thing which have only magnitude, which uh, scalar doesn't have direction. So only the difference is scalar and vectors. Scalar has magnitude and vectors has two things, magnitude and direction. So if we multiply scalar with vectors, so vectors length will increase, not direction will not change. So let's try to take one example. I have a vectors a, and if I multiply this vector by 2, so this vector will increase 2 times, but direction will be the same, direction will not be changed. So if you see this, I multiplied by scalar 2, so my vectors length goes 2 times larger or longer. If I multiply by 3, then it will goes 3 times longer, 4 times 4 if I multiply by 4, then 4 times longer. So if you see 2a is equal to 4i plus 6j. So it's so simple, you can multiply mathematically and you can get the answer 4i plus 6j. So when we multiply vectors by scalar, is called scaling. Scaling a vector, because we change how big or how small the vector is. For example, again, if I have one vectors 5 comma 2 and we are multiplying by 3, so we will get 15 comma 6. It means only the magnitude increasing but direction having same. So that's the thing, scalar multiplication. And if I ask you one more question again, what if we multiply vector a by -1, how would that change the vector? Now that's the question that I'm gonna ask tomorrow. You have to think on this. 1 minute. Yeah, now it is okay. And let's move the next thing, parallelogram law. Parallelogram is nothing, there's a way of addition of vectors. So let's try to understand parallelogram law or method. What is that? So it tell us, if we have a two vectors like this, if I have a two vectors, vector p and vector q, and if they are adjacent side of parallelogram, so their sum is represented by the diagonal of the parallelogram that start from the same origin. So if these two are adjacent of parallelogram, so the diagonal of parallelogram will be my resultant, like this. So if you can see here, if q and p, they are the adjacent side of the parallelogram, so these vector r would be my resultant. So as you remember, we have a addition method, triangular method. So if I take this triangular, if again I would take like this, so I would get, if I mirror both triangles, so I can get the parallelogram. So ultimately you will get the same answer if you use parallelogram method to add the vectors or triangular method. Now let's try to understand midpoint. Midpoint is not in your syllabus, but you have to understand this. I have a vector A, which is uh, I have sorry, not vector A. I have a line which is coordinate points are given 1 comma 2 and B point is 5 comma 6. Now we need to find the midpoint of this line. So how can we find? We have to take the vectors OA, which is from the origin, you can see, and we can take OB, other vectors. So we can take these two vectors OA and OB. So here if you see, I have a two vectors OA and OB. I have to just use the two end point of the line and we have to take the vectors from the origin. That's so simple. And what we can do, we can add these two vectors OA and OB and we can divide, then we can find the midpoint of the line. Let's see mathematically. uh, so if I have OA and OB, I 1i plus 2j and OB is 5i plus 6j. So if I add these two vectors OA and OB, so I can get 6i plus 8j. If I divide this 6i plus 8j, so I can get 3i plus 4j. It means this point, if you see, this point is 3 comma 4. So 3 comma 4 will be my midpoint. That's so simple. uh, One minute. So what if we have a point C and D? This, can you find the midpoint using the same formula? Now this question I'm giving you some time to find the midpoint of C and D. So, and tomorrow I will check, I will ask what answer you got the midpoint between C and D, and then let's try to understand, let's try to uh, recap all the things what we have understand in today's lesson. So first of all, we understand uh, what is vectors. So vector has a tail and head and direction and magnitude. That's so simple. Then we have understand addition of vectors by triangular method or head to tail method, and then we understand subtraction of vectors. Then in this we have taken the reverse of second vectors and then the resultant we got it, then we add it simply. And then next we understand parallelogram method uh, to add the vectors, and then we understand the midpoint. So this is how, this is the things we have learned today, and the questions I have given you tomorrow I'm gonna ask. So please be prepared, and if you do not understand, we will discuss and we will try to learn together. Hope you understand all the points and all the objectives. If not, then we will try to learn tomorrow all the things in next lesson. Thank you very much. Have a good day.